Hello, welcome to Advanced Algebra 2. We're still in our first unit, first learning target. Today we have the third notes. Kind of a hodgepodge, some definitions. None of them are overwhelming, but they use some examples and so forth. I started with this business on interval notation, which should be new to you, perhaps. It's a nice, actually, really quick way of writing sets, and you can use it going forward. There's nothing for me to describe on this screen that is better than you reading it, so I encourage you to read it. And then at the bottom here, I've got these bullet points that are kind of reminders of the rules of interval notation. Again, give it a look at it, and I think hopefully it'll make sense as we move through the other examples. It's actually quite nice. You can use it for any set you have to write, and it's faster, and it has less clumsy stuff in the way, like the colon and stuff from the rule method of X such that business. The interval notation will work for any situation where you have an interval, but just make sure you've looked at these 4 bullet points. It's good stuff. I'm not saying it's quite as fast as I've talked through it, because I haven't actually talked through it. I've just talked while it's on the screen. But you might need to either pause and read it, or go back and look at it later, or just kind of catch up as we go through the other examples on other topics. Okay. Intervals of increase and decrease. Now, I tried to define them here, and I got a little turned around because I was trying to avoid having a thing about an interval being about a point, which itself is about an interval. Basically, a function is increasing if it's going up, and it's decreasing if it's going down. So that's what increasing and decreasing mean. I say that slightly glibly, but you'll need to, again, we've got some examples coming up that should really help. But one important point is that interval of increase and decrease, they never include the endpoints. So we won't actually go to the spot where it looks like it turns. We'll stop just short, which, if you already understand what interval notation means, it means we'll use parentheses instead of brackets. If we were writing inequalities, we would use less than signs and greater than signs, not less than or equal to and greater than or equal to. But again, the more I talk about it, kind of the worse it gets. So read it for what it's worth, because it's true, and I did my best to be awesome for you. But we got to do these examples, because this is really where it is. Boom, look at this graph. I stole it from a test that I was using in calculus a couple of years ago. So intervals of increase. So it's increasing over there from 3 to 6, because that's where the graph is going up, like a positive slope style. And so from 3 to 6. The one tricky business about interval notation is if you don't know the context of what's going on, it might look like a point. It might seem like the point 3, 6, but it's not. It means from 3 to 6. All right, decrease. Now there's 2 intervals of decrease here. One of them starts at -3 and goes to 3. The other one starts at 6 and goes to 9. So 2 separate intervals, -3 to 3 for the one on the left, and then 6 to 9 for the one on the right. That's it for the first example. Again, those are not points. Those are intervals of x values. Next example. Intervals of increase. Well, it's increasing from -3 to 3, and then also increasing from 7 to 9. So -3 to 3, and from 7 to 9. Okay. Intervals of decrease. Yeah, that's not actually happening here. So we just have to sadly write none. Well. Okay, next example. This time I wrote the equation y equals x squared, and then talk about intervals of increase and decrease. Okay, so, y equals x squared is bloop, 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 bloop. Everybody's favorite basic parabola. Arrows on the end. Good times. Okay, now, increase. Increase is when it's going up. That is true from 0 to infinity. Decrease is when it's going down. That is where it's true from -infinity to 0. So this infinity business is a little tricky. Again, I refer you to the first page here where I talked about intervals. A lot of the examples had infinity. The one on the left for increase, it means it starts at 0. Well, it starts after 0, but immediately after 0. And then it goes forever up, so 0 to infinity. The one on the decrease one starts at infinity. That's an insane thing. I just broke the laws of the gods. It starts for all negative numbers, infinitely large negative numbers, and then it goes up to 0. Again, doesn't actually get to 0. It stops just short of 0. So, parentheses on infinities, because you can never get there. Parentheses on zeros here, because all intervals of increase and decrease are parentheses, not brackets. They do not actually include the point. Hey, moving on. Example 4. Here we got negative 2x plus 4. So, it's a line. Y-intercept is 4. Slope is negative 2. Bloop, 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 bloop. All right. It's meant to be an exactly straight line. That's kind of an iPad fail. So, hopefully if you drew it in life, you would draw it with a straight edge. All right. Interval of increase. Yeah, this line is not going up ever. So, nope. Interval of decrease. Yeah. All the way to the left to all the way to the right. That's negative infinity to infinity. Boom. That's a very large interval, because that's everything. Hey, okay. So, first 4 examples. Intervals of increase and decrease. Good stuff. Probably, a little getting used to interval notation. Also adding in there this increase-decrease business. As long as you look at graphs correctly, I will say carefully, increase and decrease is probably not that hard to notice. We just got to remember, of course, that the x's go from left to right. And so that's the way I need you to think of a graph as flowing from left to right. And that way you can gauge whether it's going down or up. But next we have this thing called extrema. Extrema is a delightful Latin word. It's plural. It's neuter plural nominative, I believe. It's plural for extremum. So we have a maximum and we have a minimum. And then again, I started to try to talk about how it was exactly true. But if you're not careful, you have to talk about intervals and then intervals within intervals. And it's kind of a disaster. But here's the big deal. If you have an endpoint of a graph, that's not a relative extrema. So, boom. Examples. Here we go. Okay. Relative minima. One relative minimum. There. Boom. Circled in red. So it's the point 3, 3. Relative maxima. Boom. 1 point. 6, 9. And that's it. Now, I'm using plural even though there's only one answer because I don't know ahead of time if there's one or more than one answer. So, yeah. Hey, example 6. Relative extreme. Okay, so minima. We're looking for the smallest point. Yeah, that's not happening. There is no point that's smaller than all the other points nearby. Okay, so none. Relative maxima. Yeah, that's not happening either. There's no point that's larger than all the other points nearby. None. All right, no winners here. Example 7, negative x squared. Let's graph it. Parabola, turned upside down. Arrows on the end. Boom. Okay. Relative minima. Yeah, there's no lowest point. Relative maxima. Winner, winner, at the top, 0, 0. Okay, one last one for today. Consider the function y equals 1/2 x minus 4. It's a line. Slope's 1/2. Y-intercept's negative 4. Done, 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 done. Okay, arrows, because it goes forever. Relative minima. Yeah, how about no? And relative maxima. Yeah, that also not happening. Okay. Intervals of increase, intervals of decrease. What the heck that interval business means. Top points and bottom points, maxima and minima. that's it for today. So, in class we'll have this assignment, some problems, and then another worksheet. I hope you enjoyed our time together, and please do let me know if you have any questions. Thank you for watching.